Alright, so now we're going to focus on derivatives of exponential and logarithmic functions. You actually already know the derivative of an exponential function. It's the one we focused on most was the derivative of e to the x. And we know that's just e to the x. But for any base, it's natural log of the base times b to the x. So it'll look something like this. Perhaps we want to know what the derivative of 4 to the 5x squared plus 2 is. Well, we just write natural log of 4 times the original. But now you have to apply the chain rule, so times the derivative of the inside is going to be 10x. So the outside function is this 4 raised to the power, and we know that 4 raised to the power is natural log of 4 times 4 raised to the same power. And then we have to take the derivative of the inside function, so that's going to be 10x. Okay, another example. Maybe go with 5 sine of x squared. Okay, the outer function is the 5 raised to the sine x squared. So the derivative of that is going to be natural log of 5 times 5 sine of x squared. But then you got to take the derivative of the inside function, which is sine, leaving the inside alone, times the derivative of the inside function, which is 2x. Possibly one of the most important derivatives that we will deal with is the natural log of x. This one's pretty straightforward. It's 1 over x. And there are numerous proofs for this. We will get into it later, but for now, just know that the derivative of the natural log of x is 1 over x. So the derivative of natural log of 4x, it's 1 over 4x, because it's 1 over whatever the thing is on the inside, times the derivative of the inside, which is just 4, so it's 1 over x. Natural log of sine. Okay, technically, if we think about it, we know that natural log can't be negative, so this is really, I guess the absolute value of sine would be more appropriate. But the reality is, it's 1 over sine x times the derivative of the inside, which is cosine x. And hopefully you recognize this as cosine over sine. Which is equal to cotangent x. Okay, one more. We take the derivative of the natural log of x squared plus 4. So it's going to be 1 over x squared plus 4 times the derivative of the inside, which is 2x. So if we simplified it, it'll be 2x over x squared plus 4. Pretty straightforward. But it's not always going to be a natural log. It might be log base 2. So how do we handle something like this? Well, we could do a change of base formula, because what we know is we know the derivative of natural log. So if I do a change of base, I get natural log of x squared plus 3x over natural log of 2. So since this is just a constant right here, natural log of 2, technically that's 1 over natural log of 2. times natural log of x squared plus 3x. So that's a constant times a function. So we can just pull that constant out and just take the derivative of the second part. So it's going to be 1 over the natural log of 2 times the derivative. 1 over x squared plus 3x times the derivative of the inside, which is 2x plus 3. Okay, and you could simplify this if you want to. Just bring everything together. And that's 2x plus 3 over natural log of 2 times x squared plus 3x. Okay? There's another way to do it though too. Alright, I got a text. We could split up log base 2 into x times x plus 3. And now this, we could use our log rules. Just write this as a sum. And now I can just differentiate this. Well, first I got to write it, change the base. Alright, so this first one is going to be 1 over natural log of 2 times 1 over x, because that's the derivative of natural log of x, plus 1 over natural log of 2 times 1 over x plus 3. And then if I factor, I get 1 over natural log of 2 times 1 over x plus 1 over x plus 3. And if you wanted to, you could get a common denominator. That'd be x plus 3. Whoopsies. X plus 3 plus x over x times x plus 3. And this is where you would get the same thing. And I know I did not actually take a derivative, so this is the derivative of this. It's the same as the derivative of this. And then we finally took a derivative.